Section 10.1, Measuring Matter. The objectives of this lesson are to explain how a mole is used to indirectly count the number of particles of matter, relate the mole to a common everyday counting unit, and convert between moles and number of representative particles. Some vocabulary review will be the molecule, and some new vocabulary we'll come across is mole and Avogadro's number. If you were buying a bouquet of flowers for a special occasion, you probably would not ask for 12 or 24. You would ask for 1 or 2 dozen. Similarly, you might buy a pair of gloves or a ream of paper for your printer or a gross of pencils. Each of these units, a pair, a dozen, a gross, and a ream, represent a specific number of items. These units make counting objects easier. If it is easier to buy and sell paper by the ream, which is 500 sheets, than it is the individual sheets. Each of the counting units is appropriate for certain kinds of objects, depending primarily on the size and function. But regardless of the object, gloves, eggs, pencils, or paper, the number that the unit represents is always consistent. Chemists also need a convenient method for accurately counting the number of atoms, molecules, or formula units in a sample of a substance. However, atoms are so small, and there are so many of them in even the smallest sample, that it is impossible to count them directly. Because of this, chemists created a counting unit called the mole. The mole, abbreviated MOL, is the SI base unit used to measure the amount of a substance. A mole is defined as the number of carbon atoms in exactly 12 grams of pure carbon-12 isotope. Through years of experimentation, it has been established that a mole of anything contains 6.021367 times 10 to the 23rd representative particles. A representative particle is any kind of particle, such as an atom, a molecule, a formula unit, an electron, an ion. If you write out Avogadro's number, it kind of looks like this. The number 6.022137 times 10 to the 23rd is called Avogadro's number, in honor of the Italian physicist and lawyer Amedeo Avogadro, who, in 1811, determined that the volume of 1 mole of a gas. In this book, Avogadro's number is rounded to 3 significant figures, 6.02 times 10 to the 23rd. To count extremely small particles, such as atoms, Avogadro's number must be an enormous quantity. As you might imagine, Avogadro's number would not be convenient for measuring a quantity of marbles. Avogadro's number of marbles would cover the face of the Earth to a depth of more than 6 kilometers. All right, if we look at figure 10.2, it shows that it is convenient to use the mole to measure the amounts of objects. 1 mole quantity of water, copper, and salt are shown, each with a different representative particle. The representative particle in a mole of water is the water molecule. The representative particle in a mole of copper is the copper atom. And the representative particle in a mole of sodium chloride is the NaCl formula unit. Right, so here in figure 10.2, it shows 1 mole of each of these substances. 1 mole of water, right, can fit in a tiny beaker. A mole of copper atoms is a couple rounds of copper wire. And a mole of sodium chloride can fit onto a petri dish. Right. However, each of these would contain 6.02 times 10 to the 23rd of whatever particles, whether it be molecules, atoms, or formula units. So each of these would be considered to have the same amount, Avogadro's number, of those representative particles. Suppose you buy 3.5 dozen roses and want to know how many roses you have. Recall that you have learned about conversion factors. You can multiply the known quantity, which is 3.5 dozen roses, by a conversion factor to express the quantity in units you want, right, which is the number of roses. First, identify the mathematical relationship that relates the given unit with the desired unit. So that relationship is that 1 dozen roses is equal to 12 roses. By dividing each side by the equality by the other side, you can write 2 conversion factors for the relationship. That you can get 12 roses over a dozen, or a dozen roses over 12 roses. Then choose the conversion factor that, when multiplied by the known quantity, results in the desired unit. When set up correctly, all units cancel except those required for the conversion. So knowing that we have 3.5 dozen roses, we're going to choose the first conversion factor so that it cancels with the dozen roses in the denominator, and that we have 12 roses in the numerator. Right? All said and done, we should have 42 roses. Now suppose you want to determine how many particles of sucrose are in 3.5 moles of sucrose. The relationship between moles and representative particles is given by Avogadro's number, in that 1 mole of a representative particle is equal to 6.02 times 10 to the 23rd of those representative particles. Using the relationship, you can write 2 different conversion factors that relate to representative particles and moles. Now you have Avogadro's number over 1 mole, or 1 mole over Avogadro's number. By using the correct conversion factor, you can find the number of representative particles in a given number of moles. Right, so you take the number of moles, multiply it by Avogadro's number over 1 mole, and that should give you the number of representative particles. And the question before was asking, how many representative particles do we have if we have 3.50 moles of sucrose? So we're going to want to go ahead and choose the conversion factor where we have moles in the denominator and then Avogadro's number in the numerator. And then when we multiply those two, 3.50 moles of sucrose would contain roughly 2.11 times 10 to the 24th molecules of sucrose. Right? So go ahead and pause the video for a second and try questions 1 and 2 in the practice problems. And here are your answers for 1 and 2. Now suppose you want to find out how many moles are represented by a certain number of representative particles. To do this, you can use the inverse of Avogadro's number as a conversion factor. You can take the number of particles and multiply that by 1 mole over Avogadro's number, and that should tell you how many number of moles you have. Right, so if we were going to use that previous example where we had 2.11 times 10 to the 24th molecules of sucrose, let's multiply that by 1 mole over Avogadro's number, and that should give us 3.5 moles of sucrose. You can convert between moles and number of representative particles by multiplying the known quantity by the proper conversion factor. Right, so let's go ahead and look at this example problem. Zinc is used as a corrosion-resistant coating on iron and steel. It is also an essential trace element in your diet. Let's go ahead and calculate the number of moles of zinc that contain 4.50 times 10 to the 24th atoms. Right, so in this we're given the value of how many zinc atoms we have, but we want to go ahead and find out how many moles that is. So what we're going to have to do is we're going to have to use Avogadro's number and that relationship to the mole so that we can go ahead and predict it. And so some things that we know is the number of atoms, and we know that relationship between a mole and Avogadro's number. So let's go ahead and use a conversion factor. In this case, it's going to be the inverse of Avogadro's number, and then we're going to go ahead and relate that moles to atoms. So let's go ahead and take 4.50 times 10 to the 24th atoms of zinc and multiply that by 1 mole of zinc over Avogadro's number. Right? Notice here how your atoms cancel out, and what you're left with is moles in the numerator. When you do the arithmetic of 4.5 times 10 to the 24th divided by 6.02 times 10 to the 23rd, you should get something like 7.48 moles of zinc. So go ahead and take a second and try to practice problems 5A and 5B. Here are your answers to 5A and 5B. In this section summary, the mole is a unit used to count particles of matter indirectly. 1 mole of a pure substance contains Avogadro's number of representative particles. Representative particles include atoms, ions, molecules, formula units, electrons, and other similar particles. 1 mole of carbon-12 atoms has a mass of exactly 12 grams. Conversion factors written from Avogadro's relationship can be used to convert between moles and numbers of representative particles.